Nice question on the trapezium rule here. But quite often they're just like, calculate this area, leave your answer to three significant figures. Well, here there's a bit more to it. So we're asked to leave our answer exact. Pretty much not going to touch my calculator for the entire question. Got the trapezium rule here, and we're asked to do it with two strips. So that means the general formula is going to become the following: half times h, and then it's going to be y0 plus y2, because n is 2, plus 2 lots of y1. Okay, essentially, I'm not entirely sure what this is going to look like, this curve, but this is what we're doing. So for us, we've got b is equal to 4 and a is equal to 0, so it's going to be 4 minus 0 all over 2, and therefore h is going to equal 2. So it's going to be just one lot of y0 plus y2 plus 2y1. So x0, the first one, is going to be 0, and then adds 2 to give 2, and then 4. When we put 0 into what we'll call our integrand, our function that we're integrating, it's just going to become a half. And then when I put 2 in, I'm going to get 1 over 2 plus root 2. And then when I put 4 in, square root of 4 is 2, so I'm going to get 1 over 2 plus 2, or 1/4. And therefore, my integral is going to be equal to a half plus a quarter, and y2 there, plus 2 lots of 1 plus 2 plus root 2. So that is going to be 3/4 plus 2 over 2 plus root 2, which doesn't exactly look like what we've asked, how we've been asked to leave it, but you can see they've rationalized the denominator here. So we've got to do that. I'm going to times by the top and the bottom by 2 minus root 2. That will sort it out. So I'm going to get 4 minus 2 root 2 when I multiply the numerators together. And on the bottom, it's going to be 4 minus root 2 squared, so minus 2. And then the 2 root 2 and minus 2 root 2 just cancel out. So that gives 3 over 4 plus, now I divide by 2, plus 2. And it's going to be minus root 2. 2 is just 8 over 4. Okay, now we can see we're there. It's going to be 11 over 4 minus root 2. Okay, great. Then it says to use the substitution x equals u squared to find the exact value. So sorry, that was part 1. Okay, we found the approximate value. Now we're actually going to use substitution to get the approximate. So if x is equal to u squared, then dx by du is going to equal 2u. And I've also got some limits. So, and u is going to be the square root of x. We only take the positive value here. So when x equals 0, u is going to equal 0. But when x is equal to 4, u is going to equal 2. Substitute my new limits in. 1 over 2 plus, and then square root of x is going to become u. and I'm going to times by using substitution dx by du, and dx by du is this 2u. So I've got 2, 0, and then 2u. Okay, this is, oh, sorry, I'm going to rewrite it as u plus 2. This is a very particular type of integral that you've got to be aware of how to deal with it. And there's two ways to deal with it. One way is to do polynomial division. So what you can't do is just integrate that directly. It's not going to be a Lun one. It's not in the form f dash x over f of x. It's not. I suppose in theory you could do another substitution. You could let like t equal u plus 2. That would work out, but that feels like overcomplicating it. Instead, the way that I would go is to like separate it into two fractions. And this is possible. Method one is to do little polynomial division. So 2u divided by u plus 2 is 2. Multiply back through. Subtract. Leaves us minus 4. So the quotient is 2. And then the remainder is minus 4. Now that has not actually been divided by u plus 2, so it becomes this. And that's what I mean by separating into two. I suppose I said two fractions. I just meant two parts here. The alternative is to write it as 2 times u over u plus 2, and then add 2 to the top and minus 2 from the top. Because what you can then do is separate it to u plus 2 over u plus 2 minus 2 over u plus 2. This bit becomes 1. We're going to get the same answer as what I did with polynomial division. So whichever way you want to do it, both are good. They're going to take us to here. Okay, we're nearly there. Right, 2u. This is a ln. This is going to become a ln integral. It's going to be 4 ln u plus 2. Evaluated still between 0 and 2. Substitute the 2 in first of all. 4 minus 4 ln 4 minus 0 minus 4 ln 2. Ln 4 can be written as ln 2 squared, and then we can bring the 2 down, so we get 4 minus 8 ln 2, and I'm going to be adding 4 ln 2. So final answer, 4 minus 4 ln 2. That is our exact value of the integral. And I've simplified it. It didn't say to fully simplify it, but you should always try and like combine the logs if you can. Right, now we're going to bring it all together. So from part one, we had that the integral was this 11 over 4 minus root 2. So using 1 and 2, let's go with the exact value first of all. We had 4 minus 4 ln 2. It's going to be approximately equal to that 11 over 4 minus root 2. What I can do now is I can rearrange it. So it's going to be 4 ln 2 is therefore going to be approximately equal to 4 minus 11 over 4 plus root 2. We're nearly there. 4 can be written as 16 over 4. So I'm going to get 5 over 4 plus root 2. And hence, so I just wanted to fit it all in, but I've struggled a bit here. And hence, ln 2 is going to be approximately equal to k. That's going to be 5 over 4 divided by 4. That's 5 over 16 plus root 2 over 4. So I'll carefully show it, which I've done here. And like I said, yeah, really good question on the trapezium rule, in my opinion.